Reciprocal function is literally just 1 over the original function. So when we're dealing with question A, and I ask you to find the reciprocal of 2x plus 5, it's y equals 1 over 2x plus 5. Really, that's all there is to it. That's A, question A done. B, finding the vertical asymptote. Vertical asymptote is just the graphical consequence of a non-permissible value. We talked about those in Unit 7. Non-permissible values happen when the bottom of a fraction equals 0. So when I ask you to find the vertical asymptote, I'm just asking you to find the non-permissible values again. So we're going to take 2x plus 5, because that's the bottom. We're going to make it equal to 0, and then we're going to solve. So to get x by itself, subtract 5 from both sides. And divide by 2. Now you're probably looking at this and saying, he's letting us use decimals? Well, yes, I am. Simply because of the nature of what we're going to be doing next. Because we're going to be graphing this, a decimal at negative 2.5 is much more useful than a fraction of negative 5 over 2. To do question C, to graph the reciprocal, we've got to take out the graphing calculator. Now, the graphing calculator is a little bit tricky with these. We cannot just type in 1 over 2x plus 5. The calculator doesn't understand that that means that the whole 2x plus 5 is in the denominator. It just thinks that the 2x is in the denominator and not the plus 5. So we need to go, and to make the calculator believe that the whole 2x plus 5 is in the bottom, we need to put brackets around it. This is going to apply every time. Every time you type that into a calculator, you're going to have to put the brackets around, and then just hit graph. Now the issue is this graph looks like it's connected. It looks like it starts pretty well horizontal, jumps down, jumps up, and then goes pretty much horizontal again. The reason that we found the vertical asymptote in question B is so that we can interpret what the calculator shows us. Calculator is low resolution. It can't show things exactly how it's supposed to be. So that line that looks at about negative 2.5, that vertical line, is actually a vertical asymptote. To graph that on the page, you're just going to take, and as best as you can on a small screen, draw a vertical asymptote at negative 2.5. It's a dotted line. Think of it as, I'm not touching you. The graph can never touch that line. So as the graph comes at it, it's going to do this. It's basically going to start hugging that line as it gets closer to it. And as it comes away from it on the right side, it's going to do the same thing. It's basically going to hug that asymptote line, never touching it, never crossing over it. So this graph is in two pieces. And that's what I need to see. Everything else is going to function pretty much exactly the same way. So if we have f of x equals 3x minus 9, the reciprocal, 1 over 3x minus 9. Vertical asymptote, we'll take 3x minus 9, we'll make it equal to 0. solve that equation. Add 9 to both sides. Divide by 3. And we get a vertical asymptote at x equals 3. Now, there's nothing stopping you from putting that asymptote on now on the graph, because you know it's going to show up there. But if you want to wait, we'll go to the calculator. We'll clear out the last function that was in there. Put in the new one. Remember which minus sign to use. It's the blue one because it's between a 3x and a 9. Remember the brackets are on the bottom. Graph it out. And it looks kind of similar to the last one. Same basic shape, but a little bit steeper. To graph it out, we need to have that vertical asymptote. This time it's going to be at 3. As best as you can. We've got the left branch that does this. The right branch that does that. And again, as best as you can. Remember the calculator limitation that the asymptote doesn't really show up as an asymptote. So you start off with a simple linear function, single x. All is good. I will make it one level more difficult. I will throw quadratics in there. So there is a little tiny bit of factoring left, but not much. It doesn't actually change the process. We still need to find the reciprocal, which is 1 over the original function. This time it's 1 over x squared minus 4. Still need to find the vertical asymptotes in this case, because it's a quadratic. We might have more than one. Easiest way to go about this is to factor it. It's a difference of squares. So it'll factor in x minus 2 and x plus 2. Split those off. We've got one asymptote at x equals 2. Another asymptote at x equals minus 2. So obviously the shape of this graph is going to be different from the previous two because we have two asymptotes we have to worry about. We're going to have two I'm not touching you places, two places to hug, but the process stays the same. We still need to pull out the graphing calculator. We still need to clear out the previous function, put in the new one, with brackets obviously. And graph it out. Looks a little bit like the Batman symbol. But again, that's just a limitation of the calculator. We know we've got two asymptotes, one at negative 2, one at positive 2. And because of the shape and the spacing of this graph, you need to be a little bit careful where you're drawing things. The very left side does an uptick like that. In the middle, we have almost a parabola-like shape. And on the end is basically the mirror image of the left side. And again, my hope is your drawing will be a little bit better than mine, just because I have such a small screen that I'm using. But the point is, can you get the general shape of this graph? We'll go through one more. A hasn't changed. A little bit more stuff to put in the bottom now. The reciprocal is still 1 over the original function. That will not change. B, the way it starts off, doesn't change. Take the bottom, make it equal to 0. To solve this one, again, factoring is probably the easiest way. We need two numbers to multiply to -6 and also add to 1. Think about that for a second. +3, -2. So we end up with 2 brackets, just like the last example. Split. Solve each equation. So we have one asymptote at x equals -3, a second asymptote at x equals 2. And again, we move over to the graphing calculator. Again, nothing changes with how we enter it. Now there's just a little bit more stuff to enter. We need brackets on the bottom. That's not going to change. We know when this graphs out, we're going to have 2 asymptotes. One of them at -3, one of them at +2. This graph, just like the last example, makes the same basic shape. An upswing on the left. A parabola-like shape in the middle. And a downswing on the right. That's literally all there is to it.